This video is going to talk about how you can solve quadratic equations by graphing. So when you graph an equation using a table, in this class since we're not allowed to use a graphing calculator, but most Math 150 teachers, when you get into 150, they'll allow you to use a graphing calculator. So if you had to solve an equation like this one, for instance, we would put it into our graphing calculator, hit graph, and then we'd have a graph of our parabola. We would know it's a parabola because the highest exponent's 2. And remember, the exponent tells you at most how many times it could cross the x-axis and how many solutions it could have. So if we were going to solve this without graphing, we could factor this. What multiplies to 6 and adds to 5? So if we factor this, we could factor it into x plus 3 and x plus 2. And then we would set each factor equal to 0. And then we would get our solutions of x equals -3 and x equals -2. And so we can see that instead of solving algebraically, that if we were allowed to use a graphing calculator, that our solutions are right here. So here's the -2, and then here is the -3. So this would be really quick if we had a graphing utility. But if we didn't have a graphing calculator, like we are not supposed to use in this class, it would take a little bit longer to have to make a table and graph it. This would be a little bit more tedious. Also, you still want to know how to solve it algebraically, because if you were to get a problem where it crosses, let's just pretend the graph were to cross like this, it would be really hard to tell where it crosses the x-axis without doing work, because it cuts through it and we can't really tell if we were to use paper and pencil and graph. So again, it says what is the solution? That means what number does x have to be to make 0. So we would get x equals -3 and x equals -2. And again, we wouldn't have to show this work if it said solve by graphing. So the graph could cross the x-axis twice and you get 2 real solutions. So this is an example where there are 2 real solutions. There's no I involved. Okay, then if we look here, so if we were solving this equation here, so I'm going to go ahead and again demonstrate using algebra. If we were solving this equation, I could subtract 1. And then square root both sides. And when we do that, the radical and the square would go away. And then when we put a radical in, we'd have a plus or minus. And the square root of -1 would be I. And then we would subtract 3, and we would get x equals -3 plus or minus I. So whenever we get an answer that has I, that means it would not cross the x-axis. So again, anytime you solve an equation and the answer contains I, it tells you that the graph would not cross the x-axis. So there would be no real solution. Okay, so if the graph does not cross the x-axis, it means you're going to have 2 complex solutions. That means you'll have I in the answer as we did here. So it could either touch twice and give you 2 real solutions. It doesn't touch, so you would have an I solution or a complex solution. And then the other situation we could have is it touches once. So if we were going to solve this algebraically, we could square root both sides. And then the radical would go away here. And then we'd have plus or minus. Well, the square root of 0 is just 0. So you can't have positive and -0. It's just 0. So you can see that this one is only going to have 1 solution. So the highest exponent is 2. And it could tell us we have 2 solutions, no solutions, or in this case just 1. So the highest exponent tells you at most how many solutions. So again, in this case, it's just 1. So we could have two real solutions, or we can have one real solution. It will touch the x-axis once, or it doesn't touch, and that means our answers are complex numbers.